so many G's during liftoff, or during the Intimidator you feel so many G's, that's why you kind of black out down the first hill. Okay, it's just how many times more of gravity. You know, you're basically just relating this acceleration to the acceleration of gravity. So let's just worry about the initial problem. So the car is traveling. Car's traveling, hits a tree. Alright, when it hits a tree, its initial velocity is 85 kilometers per hour. Well, after it hits the tree, its velocity final, he comes to a rest. It says it takes the tree 0.8 meters to stop the car. What is the acceleration? So I'm looking for acceleration. So what I would do here is, again, list my variables I know. VI. 85 kilometers per hour. Again, notice that this is not in base units. We have to change this. Okay? Change it real quick. Kilometers, meters. 1,000. Kilometers cancel out. 1 hour, 3,600 seconds. Hours cancel out. Good to go here. So I multiply on top, divide on the bottom. So I multiply on top here, see what I got. 85 times 1,000 divided by 3,600, I get 23.6 meters per second. VF, it comes to rest. Delta X, 0.8. Find A. Look at your equation sheet, figure out what equation has all 4 of these. So I go ahead in there, I go VF squared equals VI squared plus 2A delta X. VF is 0, VI is 23.6. That quantity is squared plus 2A is what I'm looking for, and delta X is 0.8. So let's go ahead and square first. Let's do 23.6 squared. It's 55696 plus 2 times 0.8 gives me 1.6 A. So to get this by itself, I'm going to subtract this first. 556.96 cancels out. Minus 556.96. So I'm left with negative 556.96 equals 1.6 A. Divide by 1.6, cancels out, 1.6 A equals 556.96 divided by 1.6. Get a negative 384.1. 348, sorry, 348. Meters per second squared. So as you can see, that's a lot higher than the 9.8 meters per second in gravity. So in a car accident, you experience a lot of G's. All right. Good. This was number 8. There you go. All right. So let's go ahead and do number 9 here. Okay, number 9. This one's a 2-parter, all right? Just be very careful. I'm going to draw this. Please pay attention to the picture. A car traveling 20 meters per second when the driver sees a child standing on the road. She takes 0.8 seconds to react, then steps on the brakes and slows at 7 meters per second squared. How far does the car go before it stops? Okay, why this is a two-part question is this. Initially, the car is traveling at 20 meters per second, all right? It takes her 0.8 seconds to hit the brakes. So for that 0.8 seconds, she's still traveling at 20 meters per second. Okay, so her acceleration is 0. She's staying at 20 meters per second. Once she hits the brakes, she now has acceleration. Okay, you cannot use this equation with a non-constant acceleration. So we have to break it up in the first part before she hits the brakes, and then the second part when she is finally hitting her brakes. So let me draw this. We'll say this point starts to apply brakes. So here, she's traveling at, I'm going to say average velocity, 20 meters per second, for a time of 0.8 seconds. Once she reaches this point, she applies the brakes. So her initial velocity is 20 meters per second. She starts slowing down from there. Okay, we need to figure out how long it takes her to come to a stop. So her velocity final needs to come to 0. Okay, we know she accelerates, okay, at 7 meters per second squared. Now here's the thing. If we've given this a positive velocity, that means this direction is positive and this direction is negative. To slow down a positive velocity, do you need a positive or negative acceleration? You would need a negative acceleration. So we have to know to make this negative. Alright? Positive velocity needs a negative acceleration to slow down. So what we need to do is we need to find delta x for each different spot. So for this spot and this spot. So I'll call this part 1. I'll call that part 2. So for part 1, I have average velocity is 20. Time is 0.8. Find delta x. Well, I can use this. Delta x t. Plug in. 20. Delta x t, 0.8. Multiply by 0.8. 0.8. I get delta x is equal to 16 meters. So the initial distance she travels before she even applies the brakes, before she touches the brakes, is going to be 16 meters. So that distance from here to here. Alright? Now, let's look at part 2. We have to figure out, using this information, how far it takes her to stop once she applies the brakes. So I have VI equals 20. A, negative 7. VF, 0. Find delta x. Alright, with that I can use the VF squared equals VI squared plus 2A delta x. I plug it in and solve. VF is 0. VI is 20 squared plus 2, negative 7, delta x. 20 times 20 is 400. Negative 14, delta x. Solve. I'll subtract by 400. Negative 14, delta x. Divide by negative 14. At 28.6 meters. So once she starts hitting the brakes and slowing down from 20 to 0, she travels 28.6. So total distance, 28.6 plus 16, which gives me 0.64, 44 meters, 44.6 meters. Okay? Anytime there's a change in acceleration, you need to break it up into different parts. Okay? Number 9, a car is traveling, or I'm sorry, this is 9. So there's number 9. We'll do number 10. Okay? Number 10. Determine the displacement of a plane that experiences uniform acceleration from 66 meters per second to 88 meters per second in 12 seconds. So it gives us from 66 to 88. So I know my VI is 66, my VF is 88. It says in 12 seconds, so it gives me time. said 12? Yes. Displacement, I'm looking for delta x. How far does the plane travel? Well, I can use this one. Let me check. The F. So I'm going to use delta x equals EF plus VI times T. I plug in. Delta x is what I'm looking for. VF, 88 plus 66 divided by 2 times 12. This one's pretty easy. I'll simplify this first. So I'll do 88 plus 66, 154 divided by 2, 77 times 12, 924 meters. So pretty easy, pretty straightforward. Just getting you to use a different equation here. Okay, let's go on to number 11. Again, it says how far does a plane fly in 15 seconds while velocity is changing from 145 meters per second to 75 meters per second uniform rate of acceleration. So now you're going from 145 to 75. So again, I'm going to change. I'm going to list what I know here. VI is 145. VF is 75. It gives you a time of 15 seconds. Find delta x. So again, I'm going to use the same one. Delta x equals VF plus VI divided by 2 T. I solve. Delta x. VF is 75 plus 145. So again, I'll do my addition first, then divide, then multiply. So do 75 plus 145. It's 220 divided by 2 gives me 110 times 15. Gives me